This is the one of the most famous endogeneity problem in economics, supply and demand estimation. So P is log of price, Q is log of quantity in market I. So we assume that there are several, like a lot of markets, and they are independent. Right? We observe, like say, market for a specific good in Albany, in like California, in other cities. Like we observe different equilibria in different markets. And the models are simplified to linear models. And of course, we only observe the equilibrium price and quantity in each market. And markets are independent and identical. Let's just calculate. It's microeconomics question. What is the equilibrium P and Q? So Q is, what is it, demand or supply? Demand. We have two equations. And let's calculate P, price. I will take minus, and then say 0 is alpha minus gamma 0 plus beta 0 minus delta 0, Pi plus UD minus US. Then if you rearrange them, Pi is delta 0 minus beta 0 in the denominator, and on numerator you get this form. This is equilibrium price, right? Equilibrium price is determined by shocks and parameters, right? That's pretty natural. And also you may calculate quantity using a similar method, like I will do. So delta 0, I multiply delta to the first equation, delta UID, and I'll multiply beta for the second equation, beta gamma plus beta delta P plus beta UIS. If you take difference, delta minus beta Q equals, let me drop subscript 0, alpha delta minus beta gamma, and canceled out, and delta minus beta UD minus delta UD minus beta US. Okay, so as a result, Q equals alpha delta minus beta gamma plus delta UD minus beta US divided by delta minus beta, right? So this is quantity. Quantity is also determined by the parameters and unobserved shocks. Okay, that is number one. As I said, like parameters and shocks. Assume the variances, and I will assume the demand and supply shocks are uncorrelated. Of course, they should be correlated, but for simplicity, I will ignore them. Calculate variance of price, covariance between P and Q. Let me copy Pi here. Alpha minus gamma, UD minus US divided by delta minus beta. And Q is alpha delta minus beta gamma plus, what was it? Delta UD minus beta US divided by delta minus beta. Okay. Then first, I will think about variance of Pi. Variance of Pi is, so this is constant, doesn't affect variance, so we ignore that. And you will get 1 over delta minus beta squared times variance of UD plus variance of US plus minus 2 times covariance, which is 0. So we will stop here. So it is sigma d squared, sigma s squared divided by delta minus beta squared. That is the variance for P. And covariance for P and Q is, so if you take covariance between them, first UD and US are uncorrelated. So UD is only correlated with this part and US is correlated with only with this part. So then you can write it as squared delta variance of UD. Okay, that was the covariance between these two guys. And covariance between US terms is delta minus beta squared in the denominator, and on top we have plus beta variance of US, which is delta minus beta squared in the denominator, delta sigma d squared plus sigma beta sigma s squared. Okay? Okay, so then what I wanted to show you here is the reason why I'm doing this is because if you are just interested in the demand function, demand elasticity, beta 0, you are interested in this beta. And then you make a wrong assumption that this demand function satisfies the classical linear regression assumption. Of course not, but if you do that, let me do this first. If you estimate the demand function using the classical linear regression assumptions, then you'll be wrong, because if you believe in the classical linear regression assumptions, then you are assuming that the beta, the demand function coefficient, equals covariance PQ over variance of P, right? Right, under the classical linear regression assumption. So this is what you think, but your truth is using these guys, right? In reality, covariance PQ over variance P is delta sigma d squared plus beta sigma s squared over sigma t squared plus sigma s squared, right? So denominator beta, delta minus beta disappears, cancels out. So of course, as you can see, it's not beta 0. You can put 0 here. So the coefficient is determined both by both the supply and the demand functions. So if you just wanted to calculate demand function, it does not work. Then why? Why? It is clear. P looks like this, and obviously it is correlated with UD. So again, let me copy it again. Alpha minus gamma plus UD minus US delta minus beta 0. Then you can calculate covariance between P and U as, so this part is constant, does not affect covariance, and also supply part does not affect the covariance because we are calculating covariance with UD. So we assumed UD and US are uncorrelated. So the covariance becomes variance of UID over delta minus beta 0, right? This is sigma d squared over delta minus beta. So it is, of course, not 0. Therefore, we have the endogeneity problem. By the way, this example will come again, will show up again in a later chapter for simultaneous equations model. We will study how to estimate the supply and demand functions at the time.